If you want to build a nuclear bomb or suggest building a nuclear power plant, you must first extract the concentrated oil. What you will see today is the entire process of extracting concentrated oil. You can like and save it before watching. In fact, 99.3% of the oil in nature is oil-238. This isotope is very stable and basically does not participate in fission reactions. What really triggers the chain is the reaction. What releases nuclear energy is another isotope that absorbs less. There is only 0.7% of the isotope in nature, which is oil-235. In order for the oil to work in the reactor, the proportion of oil-235 must be increased to 3.5%, and if you want to build a nuclear bomb, it needs to be increased to more than 90%. This process of artificially increasing the concentration of oil-235 is concentration. During World War II, the Manhattan Project in the United States brought together the world's top scientists. People like Fermi Oppenheimer and others used Japanese public relations to condense oil-235 to more than 90% using gas diffusion methods and high-speed offline machines to create the little boy atomic bomb. Hiroshima was wiped off the map in a matter of seconds in August 1945. After the war, this technology was turned to peaceful uses. Today, about 10% of the world's electricity comes from concentrated oil burned in nuclear power wars. So, where does the concentrated oil come from? It all starts from underground. The global oil deposits are mainly concentrated in Australia, Kazakhstan, and Canada. The three countries together account for more than 60% of global oil production. Oil is usually stored in a mineral called refined oil. The global average grade is between 0.1% and 2%. But there is a mine in Vancouver, Canada's SARS truck. It is the highest grade oil mine on Earth. The oil content of the mine exceeds 20%, which is a full 100 times the global average. The problem is that there is a layer of thick water-retaining sand salt above the mine. The sand salt is full of groundwater. Once it is opened, the mine tunnel will be flooded in an instant. The engineer's solution is to artificially freeze the soil. First, use a nuclear gold drill to drill more than 200 holes in the salt layer. Then penetrate the filter cover brine that has been cooled to 0 degrees Celsius and 30 degrees Celsius to freeze all the groundwater in the sand and salt into ice, forming a closed ice wall to completely isolate the ore body and groundwater. However, each pipe of this cooling system requires 8 days of construction, and the entire system requires 200 pipes. The time cost and engineering difficulty are far higher than ordinary mines. Mining can only start after the ice wall is in place. First, drill a fresh pilot hole and then use a reamer to expand it tightly. The broken ore will fall directly into the collecting gun below. During the whole process of remote control, no workers stepped into the mine because the radiation intensity of high-grade oil mines is no joke. Long-term exposure at close range can be fatal. The ventilation system in the mine replaces all the air every 20 minutes. After the ore is released, it first undergoes a radioactive scan to confirm that the oil content is between 15% and 18% before it is qualified for storage. The qualified ore is crushed, salted, and ground into powder, water is added to make a slurry, and it is sent to the mineral processing plant 50 kilometers away. There, the slurry is poured into the acid melting industry and fed into the cannon. The acid industry will selectively dissolve the oil and other impurities into the bottom. After the oil-containing liquid undergoes multiple chemical purifications, it is converted into 6 carburetor gases at high temperatures. It is gray-yellow, toxic, and extremely corrosive, but this is the standard raw material form for concentration. The 6 carburetor gases then enter the core of the concentration process. High-speed offline machine. The drill inside the machine rotates at a speed of tens of thousands of drills per minute. Although oil-235 and oil-238 both belong to the oil element, but there is a very slight difference in quality. Oil-235 burns slightly lighter than oil-238. Under strong decoupling, oil-238 will be thrown out of the drill, and oil-235 will be concentrated near the central axis. From there, it will be extracted to complete the first level separation. But this quality difference is too small. The separation effect of a single centrifugal machine is almost negligible, so it is necessary to install thousands of centrifugal machines and connect them in series. The gas will circulate through the variable, and then the oil-235 can be transferred to the negative electrode little by little to reach the target concentration. The final product is a fuchsia color powder, which is sealed in 55-will steel cylinders, labeled with radioactive warning labels, and sent to the nuclear fuel manufacturing plant. After arriving at the factory, the oil powder undergoes multiple chemical transformations and becomes an oil dioxide powder with precise and controllable properties. Then, a night duct machine is used to apply hundreds of tons of pressure to compress the powder into an O'Hara body, which is about the same size as a nuclear jacket. It is such an eye-catching little thing. The energy stored is equivalent to 800 kilograms or 700 liters of oil. The pressed new block is sent to the industrial furnace. After roasting at high temperature for a full 24 hours, all internal pores are completely eliminated, and the density and structural strength have reached the standards required by the reactor. Afterwards, the mechanical coin loads each 30 new blocks into the reactor at one time. The metal is resistant to high temperatures and corrosion, and has almost no absorption and interruption, allowing the training reaction to proceed smoothly. It is the choice of nuclear fuel cladding materials. Automatically kill the air vents at both ends of the tube. One fuel rod transformation is declared completed. 37 fuel rods are combined to form a fuel assembly. Each component must undergo a precision process to confirm it. The content of 235 fully meets the relevant requirements. Although the fuel rods contain radioactive materials, their radiation levels are relatively low at this time. Workers with advanced standard protective equipment can operate safely. After the fuel assemblies are transported to the nuclear power plant, they are loaded into the reactor core one by one. The entire reactor has a total of 480 fuel channels to accommodate 5,760 fuel rods. When the control rod is slowly withdrawn, the reaction will start. A neutron is loaded with 235 principles, and at the same time, energy and new neutrons are released. New neutrons then accumulate the next 235 and continue like this. The practice reaction is self-sustaining, stably outputting amazing heat. The heat burns water into steam. The steam drives the turbine, which in turn drives the generator. The power generation of a turbine exceeds 750 trillion, which is enough to meet the electricity needs of 500,000 people. The reactor is wrapped in a reinforced concrete body nearly 2 meters behind. Once the temperature or pressure approaches the quality of the parts, the safety system automatically